Very good. Right? So these two forces, they just add up to 0. So that in the vertical direction, there is no resultant. Add everything together, it's just 0. This is what we call vertical equilibrium. Same concept in the horizontal direction. There is same building and you got some wind load, soil load, whatever in the horizontal direction. Let's say this is wind or soil, whatever in the horizontal direction. Trying to push your building or your object, your box. And there must be something in the opposite direction, pushing backwards, so that they balance. So what could that be? That must be from the support in the horizontal direction. So that these two things, just like what we said before, cancel out. Right? They must cancel out each other. This reaction from the support. Horizontal reaction. They cancel out each other. They balance each other. So that in the horizontal direction, you can write that exactly the same sentence and only change the word vertical to horizontal. So in this case, if 10, let's say this 10 here to the left, this loading to the left, if this is positive, then to the right, pushing to the right, it must be negative, plus negative 10 to the right. And they must add up to 0. So if all forces in the horizontal direction, if added them together, it's 0. Then you have horizontal equilibrium. In other words, it won't move in the horizontal direction. It won't move in the vertical direction. But that thing still has the possibility of rotating or rotation. Why? Because this is my building. Some horizontal load, some reaction upward, sideways, just like that thing. If you try to push it like that, that thing is sitting on a ground surface. If you try to push it horizontally, it has a tendency to rotate about that point. Okay? So I just redraw my thing here. This is my point O. That thing is trying to rotate about point O because of that force P or load P. What causes that thing rotate? P and the distance. What distance? Distance from O. What distance from O? Perpendicular. This is my point O. That is the if you try to push it that way, this thing is going to rotate in the anti-clockwise direction about O. So you have anti-clockwise movement M, which is equals to P times A. Fortunately, that thing, my building, 有重量嘅。And assuming this is just a rectangle, my weight should be acting right at the center. W. So W is the weight of my object or building or box, whatever. That load, force, weight, it's at a perpendicular distance from O. That distance is my little b. Right? That is my weight, which is at a distance b, perpendicular distance from O, little b. This will give me a clockwise moment. So I have also a clockwise moment M, which is equals to W times B. In vertical direction, we talk about upward and downwards cancel out, 上下 cancel out. In horizontal equilibrium, we talk about 左右 cancel out. In rotational equilibrium, we talk about 逆時針同順時針 cancel out. So if P times A is the same as W times B, anti-clockwise and clockwise, they cancel out. So if this is anti-clockwise, let's say this is positive, you add the clockwise. If anti-clockwise is positive, clockwise is negative. So negative plus negative. This is anti-clockwise. This is clockwise. If they add to zero, sum of all moments to zero, then there's no rotation. If add anything to zero, all moments add to zero, it won't rotate. There's no moment. So no rotation. So that thing will be in rotational equilibrium. So in summary, if you try to summarize vertical, horizontal, rotational equilibrium, those three things have to be satisfied at the same time. Not just one of them, not just two of them, all of them have to be satisfied to make sure your building is in equilibrium. So in general, that's what called static equilibrium. Same time. So when a body, an object, or structure is in static equilibrium, there are three conditions you need to satisfy. First two, sum of all forces in the horizontal direction, 0. Sum of all forces in the vertical direction. So we just write it like sum. That's the symbol for sum of all forces in the x direction. That means horizontal. Horizontal. Sum of all force in vertical y direction. Sum of all moment about point O. 呢個 O 字嚟嘅，唔係零。It's 0. That's rotational. So all three conditions have to be satisfied. Otherwise, it's not in equilibrium. Right, so I will stop here for equilibrium. And after a 5 minutes break, you come back for the in-class exercise.